Good morning, bonjour, salam alaikum, shalom. This morning we're going to start off with a session on science for peace. So this is supposed to have the format of a round table, although I think all of us will be presenting a few slides. I think I'd like to start by introducing the speakers. So on my left we have Ahmed Abdelghany from Egypt. So he is a Sesame user, and he's going to tell us a little bit later on about his experiences as a Sesame user, and I guess also your plans for the future. So shukran. Then next we will have Ahmed Bassalat. Ahmed is a high-energy physicist. He got his PhD from Orsay a couple of years ago, and working on the Atlas experiment at CERN. And he's returned to Palestine. He has a faculty position at An-Najah National University, and he's now building up a group there and elsewhere in Palestine to collaborate with other countries in the Atlas experiment. So, welcome. Thank you. Then next one along, we have Patrick Fassnacht. So he will develop a little bit more the theme of cooperation between Middle East and North African countries and CERN. He is the person at CERN who advises the CERN Director General on relations with those countries. And then last but certainly not least, we have François Piuzzi, who is promoting collaboration in particular between France and developing countries. He's very interested in the problems of instrumentation, and I think he's going to say quite a lot about that, and more generally about the responsibility of scientists in the developed world to engage with their colleagues elsewhere. So thank you very much for all agreeing to participate in this round table. I'm going to introduce this discussion with a few slides of my own, and I apologize if some of the themes that I'm going to touch upon are themes that we already heard about yesterday or things that we're going to be hearing more about later on in the session. But I thought it would be useful to maybe set a sort of general context for our discussion. So, as we heard yesterday, understanding the universe is a common interest of all humanity. And I think this provides a very useful basis for international collaboration across political boundaries, across religious boundaries. And later on I'm going to be touching upon the example of CERN, but this is clearly common to many other scientific areas. Now, I also think that applying this understanding of the universe to promote development is or should be also a universal interest. And as Robert underlined yesterday, true peace is not just the absence of war. True peace is actually based on development and some respect for the dignity of our fellow human beings, which I think in particular means engaging in the applications of the science that is acquired in big research centers. So we also heard yesterday about training and education, which is going to be a recurrent theme. Research centers like Sesame or like CERN have an essential role, I think, in training and educating young scientists. And I think that we've got one or two examples sitting on the round table with us, and I'm looking forward to hearing about their particular experiences. I think all of us here believe in the ideal of international collaboration as a vector for promoting these various different ideals that I've been mentioning. CERN is one example of that. Sesame is another example of that, again, a theme that we're going to be returning to in the course of this session. And finally, I would like to underline one aspect which perhaps hasn't yet been emphasized as much as the other ones. That is what I've called here promoting scientific culture. And it's going to be something I'm going to be returning to later on. I think in these days of alternative facts and fake news, we scientists have a very essential role, even beyond our narrow scientific domains, in promoting decision-making and argumentation based on facts rather than prejudice. So, as you know, I spent many years working at CERN, and I still have CERN DNA circulating in my blood. And so I can't help but start off by reviewing actually one of the slides that Freddie showed you yesterday about the missions of CERN. But these statements, I think, apply to any other research center or indeed any other research laboratory anywhere. So one thing is to push forward the frontiers of knowledge. I think, Freddie, on your slide, you had push back the frontiers of knowledge. I think it's the alternative fact people who push back. We push forward, okay? And I'll say a little bit in a moment about one of the topics that CERN is working on at the moment, because a number of people have asked me, well, yes, but what are you actually doing at the moment? What is your personal research interest? So, Scott, particularly for you, I'm going to add in something about that. So, in order for our research to be possible, we need to develop new technologies for accelerators and detectors. And you all know about information technology, the web, the grid, applications to medicine. One very interesting new application, which we're going to be hearing about, not in this session, but later on from Martin Gastaldi, is to agriculture. I think, Martin, you're going to be talking about this later on. So I'm just going to give you a trailer for that. So training the scientists and engineers of tomorrow, that we've already heard about, unite people from around different countries and cultures. And then, as I've already emphasized on my opening slide, I want to add in a fifth mission, which is somehow implicit in everything that CERN and other big organizations do, but maybe we should emphasize it a little bit more than we have in the past. So this is the only real essential modification I made to Freddie's slide. So one way or another, I often get asked to make presentations to students or the general public about what we're doing and why we're doing it. And I couldn't resist including one slide from those presentations, which is when I was a student in Cambridge a long time ago. I had on my wall a copy of this painting by Gauguin. So these people, as you know, were asking very basic questions about us, our place in the universe, how the universe got to be the way it is, and how it is going to evolve in the future. And it's clear that these are universal questions. And this, I think, encapsulates very succinctly precisely why the study of science, and in particular the study of, dare I say it, basic science, in particular fundamental physics, in particular the sort of stuff that we do at CERN and Sesame, why this is of universal interest. Everybody is asking these questions, and everybody wants to know what the latest answers are. So, for Scott, what are we trying to do at CERN at the moment? So we're doing many things. I just picked out one particular topic. So, we scientists are very proud that we understand all the matter in the universe. Well, one has to qualify that. We understand all the visible matter in the universe. We understand atoms, molecules, stars. We even understand the matter inside Donald Trump. Leaves one or two open questions, but anyway, that much we understand. But astronomers tell us that there is much more invisible matter out there, the dark matter. And this is one of the prime topics for research at CERN and elsewhere at the moment. So the realization that there had to be this dark matter goes back to this gentleman, Piuzzi, a somewhat irascible Swiss astrophysicist, I guess 80 years ago now, who observed that galaxies in clusters were moving around very quickly, too quickly, to be explained by the gravitational field generated by the observed matter in those clusters of galaxies. So he said, well, there has to be an additional gravitational field to hold those galaxies together, and he said there has to be some sort of invisible dark matter generating an additional gravitational field that does the job. So he postulated that back in the 1930s, but I would say it wasn't until something like 40 years later that this idea really took hold in the astrophysical and physics communities. And I would pick out as a key player in this Vera Rubin. So she looked at stars moving inside galaxies, and she found a very similar effect to what Piuzzi had observed. She also found that stars orbit too quickly. We know that in the solar system, the planets that are more distant from the sun move more slowly. That's not the case for stars in galaxies. They all move around with the same speed. There has to be some additional source of gravitational field. And this, I think, many physicists regarded as being the strongest evidence for dark matter for many years. So we'll be discussing later on, it's already been mentioned on the first day, the importance of women in science. I think Vera Rubin is a great example of a pioneer in fundamental science, who, I'm sorry to say, went basically unrecognized. I personally believe that she should have got the Nobel Prize for her discovery, but she didn't. And I think this maybe reflects a basic misogyny in at least part of the scientific establishment. So anyway, this dark matter may be made of some sort of particles. There are theories as to what those particles might be. I'm not going to go into them in any great detail. But one of the things that we're doing at CERN is we're looking for these particles of dark matter. Of course, you can't see them directly because they're dark, right? They don't shine. They have very weak interactions. But maybe, certainly, they're going to carry away energy and momentum. And so we look for events where not all the energy and momentum produced in the collision can be accounted for. Okay, so that's just one example of one of the things that's currently being done at CERN. There are many others, but at least now, Scott, you know that we're doing something. So it was already emphasized yesterday, this universal science brings together now over 12,000 scientists with over 100 nationalities. Just to be sure, I counted them yesterday evening. There's actually 105 nationalities on this slide. As you see, some nationalities are not represented, and this is something which I think Patrick agrees with me we need to work on for the future. Okay, so just to finish this general introduction, I wanted to come back to this slightly more general theme that I introduced at the beginning of my talk. So, promoting scientific culture. There's some aspects of this which already have been addressed, like training young scientists and engineers, like promoting interest in STEM subjects in students in schools, which I think is also extremely important and also something which is recognized at CERN, and I think Sesame could well expand its efforts in that direction, engaging local school students. But as I said at the beginning, I think that in this current age of alternative facts and fake news, I think that all of us scientists have a key role to play in emphasizing the importance of fact-based argumentation, political discussion, and decision-making. And this goes all the way from fact-checking crazy stuff that appears on websites to trying to convince Donald Trump to actually listen to and act upon rational arguments. I'm not sure which is the tougher job. There's another aspect of this which I would like to mention, which is I think that organizations like CERN, like Sesame, in some sense represent a new organizational paradigm. I was discussing this with Rolf Fourier yesterday, and the key word here is trust. You know, we're working towards a common objective, and we trust each other to collaborate on a fair basis, although actually, if you actually examine the details, there's no firm legal basis for our collaborations. Something like Atlas, for example, collaboration of thousands of people with an enormous budget, enormous capital expenditure, actually has no independent legal status. So I think it's a very interesting question whether the sort of collaboration that we're used to as scientists may have applications to other domains. And some years ago, we had a visit at CERN by a British politician, and we were discussing, again, around a round table with him, and one of the topics that came up, and I just recall it here, is climate science. Of course, climate change is an incredibly political topic, but climate science should not be a political topic, and maybe some sort of international collaboration on climate science would be a way of sort of getting a wedge into this complicated issue of climate politics. Okay, so that sort of brings me to the end pretty much of what I wanted to say, except that I can't resist mentioning some remarks that were made by a head of state of a country in this region of the world who visited CERN a few years ago. And again, we had another roundtable discussion. And at the end of this discussion, this head of state from a neighboring visiting country commented on the fact that organizations like CERN, other scientific organizations, have this novel organizational structure. And he commented that nation states were established in order to support armies in order to conquer and maintain territory. That he said, that concept of physical territory is out of date nowadays. And I guess the events of the last couple of days in the cyber world emphasize the point that the physical world is not the only one, and one has to think in terms of a virtual world as well. Anyway, this visiting head of state, I think, sort of explicitly recommended this sort of model of scientific cooperation for something that might have wider applications. Okay, that's all I wanted to say in my opening remarks. Maybe we'll come back to some of those themes later on. But perhaps now what I'll do is pass the microphone to my colleagues, and if we want to have further discussion on some of these topics, we'll return to them later on. Thank you. So, Ahmed.
Thank you. First of all, I would like to thank the organizing committee to invite me to such event for sharing knowledge foundation. In my presentation, I would like to introduce my experiment in Sesame, and starting from writing proposal till to the paper publishing, and help that I'm get from our colleagues in Sesame, represented by Dr. Ibrahim Youssef from Palestinian Authority, Dr. Masoud Harfouch from Algerian. Both of them are beamline scientists for Emira beamline and the Basima beamline. Also from the director of Sesame, Dr. Yasser Khalil, and other colleagues in Sesame, including the two persons that we see yesterday, engineering in Sesame, Salman and Mustafa Zubi, and other colleagues from different countries that helped me during my work. The title is the Synchrone Source, a promising tool for structural evaluation of amorphous solids. Generally, people think that the glasses are formed from silicon, and this is truly not correct, because there is other network former can form glass without silicon, including borate phosphate glasses. The main issue in my work is that the structural investigation of borate glass changes because the borate glass mainly formed from two basic glass groups in this form, generally 4 coordinated boron and 3 coordinated boron, and the main issue that controls the structure and properties of such materials is what is called the N4, that's represented by the 4 coordinated boron to the total boron inside the. That's generally the problem is considered in this work is that when these materials subjected to gamma irradiation to be used as a shielding material or dosimeter, the color of this material changes or darkening, but their structural doesn't change. In other words, their spectral behavior in the UV visible region changes, obviously, while their infrared behavior is fixed in ordinary IR source. Infrared was used to investigate such material because it represents a precise method of measurement which requires no calibration, and it is also a non-destructive technique and controlling collecting scans and sensitivity. That is in general the infrared spectra of inorganic compound, which characterized by broadband peaks such that in this regardless, while other organic materials are characterized by a sharp band, a definite wave number, these bands can be analyzed to get structural data using this regime, what is called the deconvolution analysis technique, that resolve this broadband or broad peak to its individual bands, which may be represent, each one of them represent a structural group through a computer programming. FTIR mapping gave us the simple technique for investigating the N4, which represent the percent of 4 coordinated boron to the 3 coordinated boron with distribution through the material. And this helps up to define the characteristic and the physical properties changes correlated to that with gamma irradiation, which enables this material to be modified to be used as a gamma source shielding or as a dosimeter for gamma radiation. This spectra, as you see, for 3 different samples, the base unirradiated sample, and for 2 other samples that is irradiated with 2 different doses of gamma radiation, starting from 2 megarad to 8 megarad. Basically, it seems to be similar, but with the FTIR microscopy or with the deconversion assay technique, it was found that the number N4 was changes with respect to gamma irradiation dose, and this be attributed to the change in the number of non-bridging oxygen or bridging oxygen present in such material. The advantages of cyclotron-based FTIR have many advantages, including resolution and time scan, error ratio, and interference that may stray light is reduced within the measurement. I think that this is an old image for the system that we see yesterday. About 2 years ago, I think this modified. The work is done for a offline beam, and I think that in the next 2 months that will be online beam, and this figure will be changed. The output of this research is the manuscript published in the Material and Design Journal named Optical and Micro FTIR Mapping, a new approach for structural evaluation of vanadium lithium fluoroborate glasses. I think that it was published in 2050. Thanks.
Okay, thank you very much, Shukran. Amr, perhaps before we move on to the next speaker, I could just ask, so up until now, you've been working with what facility? Have you been working with some other synchrotron, or you've been working away from a synchrotron?
Until now, I'm working, I have data for work in the offline beam of Sesame Emira beamline, FTIR beamline.
Okay. And I imagine that now you're participating in one of the proposals for using the Emira beam when it comes online. So I'm just curious, what sort of an experimental collaboration do you participate in? Does it have several different Sesame member states?
The first proposal that I'm introduced is an individual proposal. That is, I'm already working. The second proposal submitted now to the Sesame Authority is a collaborative work with different other colleagues from our lab in Egypt.
Okay. I would hope that in the future it's going to be possible also for you to.
I think it was possible. The system of Sesame allowed to choose someone from the one who is registered in Sesame as a user to be collaborate with. I think that in future this was possible. Yes.
If I may ask a question as well. The paper you showed at the end, signed by you and by a colleague. The colleague was part of your institute or was part of another institute, and there is collaboration between institutes?
The collaborative for me is my professor in my institute, but in different division. He's an chemist.
Okay, does anybody from the floor have a question? Move on to the next speaker, Ahmed Bassalat from Palestine.
Good morning, everybody. Actually, I would like to thank the committee and the organizing committee to invite me to give a brief about our activity in Palestine, or at least in my university. Actually, I'm going to speak about first winter school that we organized in high energy physics in Palestine last year. Or you can give another title that what has been done after November 2015. November 2015, it's not my birthday, huh? It is the previous or the last conference for Sharing Knowledge Foundation. It was in Trieste. So actually, personally, I went to France in 2008 to finish my master and my PhD. And then a few days after that, in December 15, the plan or the idea has been cooked in the LAL director office about what can we do about this school and what is the course that we teach and what's the time scale and everything related to that. And then in the last slide, we will comment later on. So actually, we were speaking and discussing with many people who are supporting our efforts to create such school, and we were speaking to International Advisory Committee, and we set up a program committee. So we spoke with Annick Weiner. She was a French former consular in USA. Then we have Professor Etienne Auger. He's vice president of Paris Sud, which is the university that I was doing my research and my study. Then we have Professor Al-Jaber. Then we have Dr. Khalid Toukan, who is the Director General of Sesame. Then additionally to that, we have Hervé Saboura. He's the Director of Agence Universitaire Francophonie au Lebanon. Then we have the former spokesperson of Atlas, Peter Yani. And then we have Professor Rolf, who's with us today. And this is a photo or a picture when the Palestinian ambassador for the international organization in Geneva signed an international cooperation agreement just a few days after that discussion that I spoke about in December 18th in 2015. Additionally to that, we have continuous discussion and advices and really a big collaboration with our pioneers, John Ellis and Patrick Fassnacht, and here you have Robert and Rolf and Patrick. They were extremely happy when they signed, the agreement in order to finance some Palestinian student to carry out his PhD at CERN. Then about our colleagues in the program committee, he was the Achilles Touki, who is the director of Linear Accelerator Laboratory at LAL, and he is the co-creator of WISHEP School. Then we have this nice woman. She's Hadil Abu Arrob. She's a professor in the physics department in An-Najah University, and this is why she was leading the opening ceremony for our school. Then we have two professors from the experiments we call LHCP at CERN, Marie-Hélène Schoon and Frédéric Machouffer. Additionally to that, we have a professor from Soleil, France, who was the ex-technical director of Sesame, by the way. He's An-Najah. And then we have Florent Robinet. He's a researcher in Virgo, which is one of the experiments that just discovered or participated in the gravitational waves discovery last year. And we have, I think a lot of you know him, Jean-Marc Lévy-Leblanc, who is a professor in theoretical physics in Université de Nice. So what about our program? It was in 13th to 17th November. We have agreed that We are going to do 4 different activities and 4 different audience. So our targets were the physics students and university students, in addition to public people and school students. So the first one, it was lectures actually in the morning. Each day we have 3 to 4 lectures in physics in hot topics like particle physics or Higgs discovery, gravitational waves, and detectors, accelerator. It has been given by the people that I just told. And then we have each day, in that lectures, it was targeted to the students in the university and let me say undergraduate and graduate students. And then we have like general seminars for, let me say, all the students in the university, non-physicists. And then we have a project session that we need the teamwork between the students and inspire them. And one of the important aspects for the school, it was to speak to the parents of the students and to motivate the students for the natural sciences and for the physics in particular. So we held a soirée, a public event, where all schools, teachers, professors, and general publics were invited. And in this picture, you will not see, you don't think that all of these are very old Palestinians. No, no. These are professors, the team, the European professors that participated us in the conference. And we have, we let them wear the Palestinian kufiya, we call it. So it's a new style, and they like it, by the way. So if you like to join us this year, we will wear you one of these. And the fourth one, which I, let me say, stole it maybe from Frédéric, that we have to give really an interest for the young generation, for the students in the schools. So this is why one of our topics, it was directed to the young students, to the school students. So we were inviting school students from different cities, from different schools, 17, 18 years, in order to let them what we can do, in particular in high energy physics or in physics in general. So we were giving them seminars about the color of sky, about by Jean-Marc Lévy, and about the particle physics adventure. What does mean CERN? What is a colliding beam? What's everything related to the high energy physics. Then from our excursion here, Akil Stuki, he was wearing the traditional casquette in Nablus, which was weird long time ago. And here some activity from the public event where some Palestinian traditional music and dance. And as you see, the school, it was in November, which is the semester, or which is the season of the oil and olive, fresh olive. So we went a trip to the olive presser machine, which is in my own village. And here our colleagues, they were very happy when they have really a freshy olive oil. So if you would like to hear about some secrets in the school, we were planning for a school to be local, to be for 20, 30, 40 students maximum in the university, and let them know what does mean CERN or high energy physics. But we found ourselves that we are receiving more than 130 applications. And this application, by the way, we were announcing only for 45 students. And personally, I had in that day a fund only for 45 students. And at the end, I received more than 130 applications. These students were distributed from An-Najah National University in Nablus and Palestine Technical University in Tulkarm and another Arab American University in Jenin and the Birzeit University in Ramallah. So we were trying in the application form. I was putting some few questions in order to be tricky, in order to be able to choose, let me say, the students or the 45 students. So I was asking these 2 questions, which are in red. Will you attend the lectures of November 15th? Actually, November 15th, it's Palestinian National Day, which is a holiday, an official holiday in Palestine. So I was thinking that the student will not come, and like this, they will lose, let me say, 20% of the school, as it is for 5 days. So I was shocked by finding more than 90% of the students answering, I know it is a vacation, but I will attend the lectures. Another question, I was saying, you are interested in which? In the whole school, in the public event, in the general seminars. I found more than 93% of the students saying, I'm interested in the whole school. So after all of that, we have decided to double, even more, the number of accepted students, and we agreed with our speakers to doubling their efforts because we are going to parallelize the lectures during the whole day. And this is just an official picture for the opening ceremony, which has been attended and supported by the Minister of Education and Higher Education Palestine, and the acting president of my university, and the Minister of Telecommunication and Technology in Palestine. And this is, as you see, the group picture for the participant. So you will see that the majority in our university, maybe, or in the school in particular, they were women, by the way. As a result, for the school, we have awarded by four scholarships to Tasneem and Hind. And Hind, she's just here. And these two girls, they are nowadays in Paris. They are finishing their master degree under my supervision and another colleague there. And they are going to back by next month. And we have another two students, Shaima and Manar, that they just yesterday informed me that their visa has been delivered after a delay of almost 1 month, and they are traveling by tomorrow or after tomorrow maximum for doing their internship. Additionally to that, actually when I returned back also to Palestine, I had always motivated my students to the Sesame sciences related there, and we have organized a visit. It's exactly like the visit that you did yesterday, but unfortunately it was not like yesterday. I mean, a lot of things were not still installed, and yeah, we took our group photo here, and then this visit has been followed by a discussion with Dr. Tukan. And this is almost the last picture. This is the student that we spoke about here yesterday that called Zero Proposal. She's awarded by a scholarship called ICTP Sesame Fellowship, and she will begin her work on Sesame by September this year. So, and this let me to conclude that a yearly based school mainly during the winter, even if it's not running in Palestine in winter, but there will be a school each year. This school opened the door to the students really for the current research in high energy physics generally, and synchrotron-related sciences, and sciences related to CERN or Sesame or these international institution. As I said, 4 students have been awarded by scholarships, and as you saw, all the 4 students are girls. So always I'm saying the boys have to show up in the university. As my personal statement, as I always say, the international collaboration is the easiest way for countries with relatively small scientific communities, and limited budgets to develop their research and their sciences. And without any doubt, Sesame will improve the research quality in the region. And this is, let me say, an open invitation for all of you to attend our second WISHEP. It will be in 11th to 18th November this year. And there will be a lot of excursion and nice and social events. And thank you very much. No, sorry, but you didn't hear the last slide. So, as I said, it was an idea born there, but it is really a collaboration between all these institutions. And from this stage, I took the chance to thanks the people at LAL in particular, and CERN, CNRS, and Consulat Général de France à Jérusalem, and DPG, and LHCP and Atlas, Soleil, Agence Universitaire Francophonie, of course, An-Najah University, Sesame, and Paris Sud, and Baslamani. So this is what I want to say, that it was an idea, but it has been carried out by more than, 15 institutional and university and funding agency. Thank you very much.
Okay, thank you very much, Ahmed. Does anybody have any questions for Ahmed? Yes.
Congratulations for this project. It's a beautiful idea. I would like to know what will be in the long term, the perennity of this. I mean, do you have a budget to ensure your credibility?
You mean about on long term, right? On long term, you said? Yeah. Personally, I hope we. Oh, sorry. I hope, as I wrote in one of the slides, it is or it was a local school. Then naturally, it becomes a national one. And on the long run, I hope it becomes regional, even international school for all students from all over the world, and to be each year in one of the countries.
Robert.
Ahmed, you went to CERN and you worked at Atlas, and now you're teaching at the National University and at Naples. And my question is, two things. First of all, you have all these students. What will their future be professionally? I suppose that some of them will become engineer, or maybe, hopefully, will start up small innovative companies. That's one thing. But on the other hand, you have been doing some work with the Atlas collaboration. Do you see your future as coming back sometime to work at Atlas and maybe have other young people coming and contributing to Palestinian science in high-energy physics?
Yes, this is very important, of course. And this is what I'm doing nowadays. So as I said, one of the students, or there is two students, as I said, left already to Paris. They will come back by next month. One of them is working with me in Atlas experiment on the new project in our tracking system for Atlas. So this is to let me say, to stay with contact with my colleagues at Atlas in particular, as I'm an Atlas member. And of course, to transfer this knowledge about high energy physics in general, or about Atlas technology, to my institution one day, and to build a lab, and to be more active in the community and in the collaboration.
Yeah, you talked about over-representation of women in your university. And I was wondering, because it's exactly the opposite in France, there's a huge over-representation of men. So has it any meaning in terms of image or representation of physics in your country?
Well, I think that it depends on many reasons. But at least I can summarize one, which I think it's one of the most important, or which is the leading factor for that. The teaching in Palestine is paid. So when you want to go to the university, your father has to pay for you when you go to the university. And maybe it's a general policy for Palestinians that they take care about their girls more than their boys. And we have to teach our girls more than our boys. This happened, at least for my family. I have 2 brothers elder than me and another sister, so 3 above. two of them, they finished their baccalaureate, their secondary school, and they were succeeding and everything is fine for them. But in that day, my father was not having enough money to let them to go to the university. However, the third year, my sister succeeded in the baccalaureate, and my father was obliged to put her in the engineering faculty. And then she was in the university, however, two of my brothers were not. Then they got a scholarship from Iraq, and they went to Iraq. Then the war of Iraq happened, and they come back to Palestine. Then my father has been retired from his job, and he was a doctor. And then he became working many things in order to bring money for his, for my brothers.
There is the question which you mentioned, which is very important, of financial support for people wanting to study universities. So my reflection, and I've discussed this already with John Ellis, is there are indeed in the Palestinian diaspora, for instance in California, very wealthy people. Beardside, after all, one of the main universities, is a private university, and we can all see that this is flourishing. So is there a possibility to have this influence, the fact that you've been so successful in studying at CERN for a PhD and now transmitting this to Palestinian students, would there be a possibility that people from the diaspora understand the need to have some fellowships, for instance, for Palestinian students to come and study in universities, either in France or in Europe? In France, it's easier because, as you know, the French universities don't charge. But if you want to go to the UK, it's very expensive, etc. John, do you want to comment on this? I know that you've been trying.
Let's first of all hear Ahmed's perspective. The Palestinian diaspora, can one expect anything from them?
Actually, there is some dedicated funds, one from the presidency office, and there is a governmental fund to support the students. But at the end, you cannot become in one day like France, for example, or Europe in general. I mean, you can support 20%, 30% of the students that are coming to the university, but you cannot support 100% of the university. Take an example for An-Najah University only, you have around 30,000 students. Maybe half of them in Birzeit, third of them in American university, blah, 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 which is in total, I think there is 50 to 60,000 students in the university. Around 15,000 each year of them has been graduated. So you can fund partially, which is the case, but you cannot fund all. Otherwise, we will become a real European style in teaching, which is, I think, expensive.
Yeah, I've made some efforts to interest the Palestinian diaspora in giving some finance for students, individual students, but never with any success. I don't know whether it's just because I didn't put enough effort into it or whether they weren't so interested, but anyway, it just didn't work out. Anyway, perhaps we should move on now, so thank you very much, Ahmed.
So good morning. It's a pleasure for me to talk to you after Ahmed's talk, because Ahmed is a perfect illustration of what we are doing at CERN in terms of training and then see the people going back to their country and then spread out what they got from CERN or from LAL in this case. And this is really a very nice illustration of this training and outreach. So then my second point as an introduction, I feel a bit bad here now talking after Freddie, Baudry and John Lewis, because so much has been said about CERN. So I'm going to concentrate about CERN and the Middle East and North Africa relations, collaboration. But some of the slides you have already seen, and I apologize for this, but I really will try to concentrate on the Middle East and North Africa, covering the various points about the various outreach and training programs we have, which are the summer students, the high school teachers program, virtual visit, Beamline for School, etc. There are many activities. So my first slide is then about what is really going on in the Middle East and North Africa, and you see here the map of that region, and you see, I mean, all kind of relations, collaborations we have with the different countries. In blue, there are the list of the countries with whom we have signed international collaboration agreements. So you see there is a quite long list, and if you go by alphabetic order, it's from Algeria, Egypt, Iran, Jordan, centered around the Sesame program, Lebanon, Morocco, Palestine, Qatar, Saudi, Tunisia, and the Emirates. So you see it's a quite long list, almost complete for the Middle East and North Africa. In orange, there are 3 countries, Bahrain, Kuwait, and Oman, with whom we have some scientific contacts, and we are thinking about signing in future a collaboration agreement. The next probably will be Kuwait, where we are in contact with the Kuwait Foundation for Advanced Science. And in green, the teachers program, and I will tell you more about what is going on, and you see the full list. For the teachers program, there are 2 kinds of programs. There is an international program and there is a national program. And what is really of interest is, I think, is the national teachers program. And we have started in the 2 countries here, Algeria and Lebanon, and we are discussing for such a program in Palestine for the coming years. And then in yellow you have them in the summer student program, and you see all the countries that have been so far involved in this CERN summer student program. So the next slide, this you have seen now probably 2 times. But as I said, I'm going to concentrate on the Middle East and North Africa. And you see that the total number out of the 13,000 users at CERN, we have coming from Middle East and North Africa, order of 80. And the big contributors are Egypt, Iran, and Morocco. Going beyond the Middle East and North Africa, I mean, you see here that there is really an effort that we need to make in order to get more countries from Africa into our activities. So this is a distribution by institute, meaning that the people collaborating with CERN, they have a home institute in the country. Now, if you look, and this has been shown by Borate yesterday, if you look by nationality, the situation is completely different. And you see here now that it sums up for the Middle East and North Africa to the double, 260, okay? And now I have made this simple ratio between users from institute versus users by passport, by nationality. And for the MENA, it's 80, the previous slide divided by 160. This is easy, gives you 0.5. And if you do the same for the US, it's exactly the opposite. Meaning that, I mean, for the US, there are people from outside going to the institutes in the US contributing to the CERN activities. This is what we call the brain drain, and this is something we have to see if we can inverse the tendency of this. And finally, a last word about this on this slide, which is by nationality, the contribution of Jordan, where we have 2 users at CERN. So this is the comment I made yesterday. We clearly need to make an effort towards the universities in Jordan. So this is about the couple of official events we had at CERN over the last year. with the in the region. I mean, Afghanistan is maybe a bit at the limit, but here we had a visit of the ambassador. This was in July 2016. Then we had the signature of a cooperation agreement with the Qatar Foundation. This was in March 2016, and you see our new DG here, Fabiola Gianotti. Later we had the visit of the Dean of the Sharjah University from the Emirates. And just as a comment, this is a student, he got his PhD, he's from Algeria, got a position at the Sharjah University, and now, like Ahmed, is doing the effort to build up a community for high energy physics. Then we had the visit of Bahrain, this was in March 2017, of Her Highness Sheikh Hamay, and we were discussing here about a regional center between, is it mine? A regional center in to make the contact to CERN between Bahrain, Kuwait, and then this same discussion we had when we had the visit, which I mentioned before, of the president of the Kuwait Foundation for Advanced Science. So there is the idea of getting a kind of regional collaboration between CERN and some countries in the Middle East. So now my next slide is about the summer students, and this is the situation that it was last year. And again, focusing on the Middle East, you see we had in 2016 we had 18 students from the Middle East and North Africa. We made a small effort, an additional effort in 2017. We are now up to 20 students. We could eventually go for more, but at the end, it's always a problem of getting the finances at the right moment. And this is why if we actually we try to follow this rule, which is a kind of 50-50. So, I mean, CERN pays for half of the students, and half of the remaining students, we need to find resources from outside, so what I call here non-CERN funds. And this comes from the home countries, can come from some foundations. CERN has a foundation, CERN and Society, helping out in paying for some of the students. And then, I mean, to continue on the comment made before, the ratio for the summer students between male and female is close to 50%, which is much, much higher than for any other region in the world. So in the Middle East, North Africa is really close to 1. Yeah, sorry. This is the 50%. I don't know why I have written 50%. It's 50-50. So it's 1-to-1. So sorry for the 50% discount. So this was about the summer students. Now I move to the high school teachers, and you see a couple of nice photos. First of all, this is a very old one. This is a much recent one where you see Rolf Fourier here. I mean, talking to the teachers, and they have spent a couple of time together, and in order to explain really what we are doing at CERN, etc. So from the Middle East, we got a total of 41 teachers. And there was a specific program about Sesame that took place in 2015, where we got to CERN teachers and students from each member states of Sesame to spend 1 week at CERN. Then, as I have mentioned before, there are these national teachers programs. We had one for Algeria in October 2016, Lebanon, April 2017, and we are discussing to have one in Palestine. So these are all the specific activities in the Middle East concerning the high school teachers program. And just to illustrate additional activities in the region, organized also by the experiments, because the experiments are also quite active, not only CERN. So this was an event organized by the Atlas experiment, an Atlas virtual visit. This was to Palestine, to Jenin, and you see the This is the Jenin side, the students in the classroom. This is one lecturer here he was at CERN. And the same has happened also for the CMS experiment, and they had it with Lebanon. So there are many contacts also between the experiments and and some of the classes in the Middle East and North Africa. So finally, also just to point about some other activities which concerns the younger people. And there is a program which is the school students program. And this is really, I mean, to get a feeling to the students what we are doing at CERN. So slip into the skin of a researcher. And this has quite good success. And then there is also a program for high school student teachers, the school lab, so it's school to learn what we are doing at CERN. And this also has a good success. The beamline for school was mentioned yesterday. And it's nice to see that for the beamline at school, we got 37 proposals. We got 37 proposals from the Middle East and North Africa since the start of this. And then we have a master classes organized. This is one here in Palestine. So you see there is quite some activity in order to train and to build capacity. So then I wanted to show you on one slide, in fact, what the Sharing Knowledge Foundation is doing for the effort we are doing, and how the Sharing Knowledge is contributing to it. And this photo you have seen by Ahmed, which is the time we had the signature of this agreement, which gave to the Sharing Knowledge Foundation somehow the possibility to recruit students on a technical or doctoral student program, and then get approved by the CERN committee, and then they come to CERN, they spend 6 months, they spend 1 year, they spend 2 years at CERN, and they are partially or fully paid by the Sharing Knowledge Foundation. So the Sharing Knowledge Foundation organizes the selection of the candidate, which is then, as I said, endorsed by the CERN committee, and the payment goes via Sharing Knowledge Foundation. And the recent activities, the successes of this program, there are essentially 3. Sharing Knowledge Foundation gave support to a student from Morocco, Gouigri. In the meantime, he has a position in Agadir as an associate professor and is quite active in order to also, get some students from Agadir into the field of high energy physics. Then there is a recent one, which is Mr. Al-Stati from Jenin, Palestine. He's in the process of defending his PhD, which he hopefully will defend by the second half of this year. And then the very recent thing and new is that the Sharing Knowledge Foundation will contribute to a position for a student from Gaza, Palestine. So we have made a selection of a student. It has gone to the committee, has been approved. We are now in the process of making all the invitation letters in order to get the student to CERN. And finally, my last slide about MENA and CERN is this one, in which I show you, first I thank you for your attention, but the second point is I wanted to show you, how much MENA is present in the publications. If you go to any Atlas publications, and there have been so far order of 500, the first 2 authors are from the MENA region. So the very first one is from Morocco, and the second one is from Lebanon, and this is out of more than 2,000 authors of a given paper. Thank you.
Okay, thank you very much. Patrick, any comments or questions for him? Ahmed.
Patrick, thank you, Patrick. Can you tell us about this program for the teacher that you spoke about, because we can, collaborate or help in holding it in Palestine, as you said?
Yeah, this is this national program. And so, as I said, we had it in two countries, Algeria and Lebanon, and we are discussing to have it in Palestine. We may have to coordinate a little bit better. I see where you want to point on, but this is discussed with some people, and we need maybe to coordinate a little bit better.
I'm coming back to my previous question about, having money from the diaspora. It is absolutely clear that this will come if you have success, and if success is publicized, as we've seen now with Morocco. Money goes to those who have success, and of course, people tend to be proud of their country. It will not happen overnight. It will happen over time, but I think this is the way to go. If you know that physicists from Palestine have publications coming from Atlas, from the next step in the sea, and this is publicized in the international press, then you have a chance that it will improve. Also, well, Palestine is a poor country, but it is emerging, and as time goes on, I think you may succeed, but this is the way to go. Thank you.
I can't resist making one little comment, which is that when we initiated this program of having Palestinian students coming to CERN as summer students, initially they were funded by Israel. Israel provided funds to CERN with the understanding that this could then be used to support Palestinian students. This is how it started. I think there's another topic which maybe we need to understand better, which is this male to female ratio. But maybe we come back to that later in the course of this meeting, because I think we're running close to the end of our schedule.
As Frederick told us yesterday, peace involves different things. And for most people, peace involves better living conditions. For example, with environment, water quality, purification, removal of contaminants, also for health, vaccine, low-cost diagnostics, which means low-cost X-ray apparatus, MRI, etc., appropriate medicines. Also, improvements in energy, like direct production in isolated sites to improve living conditions. And all this begins by improving education and improving scientific training. So we should maintain high quality of basic science, like in CERN, so as to be able to answer basic questions and improve knowledge. So first I want to tell a warm welcome to Sésame for the future. So I am speaking on behalf of the Physics Without Border Commission of the French Physical Society and also of the Association pour la promotion scientifique de l'Afrique. So one of the ways to develop experimental sciences, because I will talk about experimental sciences, is to distribute widely scientific instruments. Ideally, these should be designed and built locally, and to organize trainings with the new tools and new methods that enable manufacturing at affordable cost. Numerous solutions were brought recently by what we call the digital revolution. As, for example, the 3D printing, open source approaches, sharing approaches. So sharing is really what is brought also by this digital revolution. It was not possible before, or it was more difficult. So, for example, a movement whose name is GOSH. GOSH means Global Open Science Hardware. It was born 2 years ago. It was induced by young scientists in Europe and the United States. So they try to share different instruments which are which can be made with affordable cost. Then there is in Switzerland, there is also a group of young scientists which are under the name of Gaudi Lab. They also are making scientific instruments at low cost. And in Germany, there is an NGO, whose name is Trend in Africa, who also tries to make affordable cost instrument. So I think that we should try also to democratize science, to put it as close as possible to the citizens, to help them to understand scientific processes. The emergence of citizen science is for me very important, even if that is stirring some suspicion from a lot of scientists. You know, violences arise when things are not understood. So this is also important in popularizing different aspects of science. About citizen science, you have different NGOs working on that. For example, in the USA, you have the Public Lab, which is making measurements which are not made by official institutions. In France, we have CRIRAD, which is an NGO which is making measurements which are not also made by some institutions. And in USA, for example, you have an official institution, this an Environmental Protection Agency, which gives some hints to citizens to make measures of contaminant gas for citizens. So directly from an institution to the citizen, that's, I think it is a good thing. So also what we can do is to use new technologies, that nanosciences, plasmonics, together with new components to develop new applications. So that is being made. And one way also is to reuse high-tech components that we can find in different mass-produced devices, which is more ecological also. In this aspect, you have, for example, an example of in Africa, in Togo, some people made a 3D printing directly out of what was electronic scrap in the city. So it is the first example that I found in Africa. Another aspect using new breakthroughs is in Manchester. You know, the lab where they have 2 Nobel Prizes for graphene. So now they found that using graphene oxide, you can make a membrane for water purification. Okay, this is just a first paper, and perhaps it will take 10 or 15 years to succeed, but it is a new thing. And also we should take care of how how we do things with, for example, Africa. And recently, I think it is 15 days ago in Benin, there was a refusal to accept all medical equipment for France because they thought that it was better to buy directly new ones. And so that's, we should take care of that. So going back to scientific instruments, you know, the problem is that scientific instruments are very expensive, very expensive to be democratized. And generally, industrial companies are not interested in developments with a return on investment that is not insured or that is only hypothetical. That's a problem. So now a lot of some developments are triggered by scientists wanting to help other scientists in different parts of the world. Recently, 2 things were really striking. It's Arduino electronic platforms that enables every scientist to use electronics. And also in England, in the United Kingdom, you have a charity which developed the Raspberry Pi microcomputer for a price of about 30 euro. So with 30 euro, you get a microcomputer to command an instrument, for example. So what it is strange to see is that was developed very marginally, but due to the success, now these two things are used by industrials. So that's something strange. Also a thing which for me is important, science also should do its best to help handicapped people, especially in physics. And in this field, the impact of science is still marginal. And the products which have been developed are expensive, too expensive. Nevertheless, some individual researchers are working in this field. And I know, for example, Professor René Farcy at Université Paris-Sud. And he developed an electronic stick for blind people. Now he reached the third generation of that. Also from English charities, there is a low-cost pocket ophthalmoscope that for €7 you get a sturdy instrument to just make basic investigations for people. And now also you can have articulated arms with Arduino control. And basic research is also currently underway in this field. For example, mind control of arm or of artificial arm in this field. So what also is important is that all scientists should have a role in helping and in cooperating with developing countries. So that I put that learning societies, international associations, and different organizations. I have an example of that is that 3 years ago we had the International Year of Crystallography. And during this year, the vice president of this association made a strong action. So he found different instruments, diffractometers, and he found also some industrial willing to repair them. And so he could go to 20 countries with these diffractometers and making training. So it was the first time that scientists really did this kind of action in Africa, South America, and also Asia. So this is the first thing, but we have more things to do. We have in developing countries, you find a lot of students. I went to Yaoundé University, and the first and second years in physics, the amphitheater was full with more than 1,000 students. The problem is these 1,000 students, you don't have enough instruments for making practicals with them. That's a big problem. And you know that now, since information is flowing quickly, all people know that the situation is not normal compared to the situation that we have in our countries. So I think we should have a strong action rapidly, because otherwise, you know, there is also violence which will arise from this situation. And we should do something. So, for example, with the Association for the Promotion of Scientific in Africa, we started a competition for equipment for experimental physics directly in the country. So we had about 20 candidates. 10 were selected for the second part of the competition, and now 3 are selected to make a prototype, and then the final award will be selected. So other organizations are working in the field of cooperation with developing countries. You have CERN. Also, the European Physical Societies, they have a special fund now to help some initiatives in low-resource countries. You have ICTP, TWAS. You have the IUPAP C13. And you have also, very important in Sweden, the International Science Program. You have also, it was made mainly for mathematicians, the Next Einstein Initiative and the Ames Institute in South Africa and now in different African countries. And now our commission, a small commission, we are trying to have actions in Haiti, Mali, Madagascar, Senegal, and Cameroon. And I also want to tell you that UPAP is thinking about a new synchrotron, to build a new synchrotron in South Africa. But it will be in 10 years or 15 years. Thank you for your attention.
Okay, thank you very much. I'm particularly interested in the ideas that you're mentioning about low-cost experimental apparatus. I think it's interesting to think that, all of our houses have a lot of sophisticated electronic equipment that could be repurposed. And I think this could be done, as in fact we were discussing over breakfast, not just in low-resource countries, but also in developed countries, where often students in high schools don't get to do as many practicals as they should do.
Yes, I think on this question of having instruments which are low cost, when we did this experiment at Isolde to find the resonance radiation of francium, we used dye lasers and all kinds of equipment worth millions. Now you could find this because of the mass market for less than $100. So this is very important, a very important development. And I think what you're doing with having low-cost laboratories is really laudable and a very important initiative, because science progresses by having collaboration with big institutions like CERN, ESA, etc., but also from the ground with the imagination of people and the resources from the mass market. So this is my first remark. My second one is the following. This is a suggestion which will be discussed, I hope, when we make our recommendations. Right now, people who study at CERN for their PhD get their PhDs from France, like Orsay, Marseille, or from Germany. But at some point in time, I think it would be wise for the National University of Palestine to be granting itself a PhD. I think there's absolutely no reason, because the cost is nothing, because the work is done at CERN. So I think it would be very important at some point to have the possibility and also being proud to be the first to discern a PhD from a Palestinian university in high-energy physics.
Actually, we have a PhD program in An-Najah University, but maybe we don't have a lot of students.
But has there been a Palestinian working at CERN or abroad who has been granted a PhD by the National University, rather than a French or UK or German university? I think it's worth discussing with the government of Palestine.
That's right, not yet.
So some other comments or questions?
Hi, a question for François. You mentioned that you've been working on developing some various kinds of low-cost solutions and applications from the science work that you're doing. Have you worked with the private sector in terms of sort of commercializing and then widely distributing some of these solutions? Have you found good partners? Because there's been a lot of discussion about collaboration among the scientific community, but really to be effective, the collaboration has to be deeper than that. It has to also be with the private sector and the public sector.
Okay. Actually, there is a problem, because when you go to open source approaches, the problem is that you don't have patents. Or you have special patents like CERN is trying to develop, like the open license, open CERN license, open hardware CERN license. And this is still a problem, because we are you have new things, open source approaches are new. So now, how to cope with that is not so easy. So it is why the relationship with industry is not so clear. If you don't have a patent, they will not come easily. But they can use, for example, Arduino or Raspberry Pi microcomputers are used even by industry, by the industrials.
Yeah, coming back to the low-cost detectors, there is a fantastic program in the UK. That's Betty Parker, the teacher. And they develop and have developed low-cost detectors for schools, and they are used in many regions of the UK. So the question is, couldn't that be expanded into an area like the MENA? I think that one should check out with Betty. And I know that she triggers a lot of young people to go into study of natural science. They come many come from her region. And they now even have an experiment sent, I think, even to the ISS on a very low cost. So that one should inquire, to my mind.
Okay, I have also an example that we made a workshop with regular people, not scientists, and the goal was to make a microscope using a webcam. And in half an hour, you can get your microscope. And that is important, for example, for schools, for primary schools, even for high schools, and even the teacher can make it. It's not really difficult. And since now you get directly your image to your computer or to a screen, so you can show this very easily to the pupils. And I think it's now we have solutions, low-cost solutions, efficient low-cost solutions to do that. But you should popularize that. You should train the people to use that.
Yeah, just to pick up on Rolf's point. So I think Becky Parker is a really remarkable person. She's a physics teacher in one particular school in England, which has produced a very large fraction of the physics students nationally. And she indeed has helped with her students to put experiments into space using CERN technology, by the way, using time-pix technology. And in fact, she is now, together with some of her colleagues, a signatory on experimental papers from the LHC. The medal experiment has her group as official collaborators. We're not quite at the stage of having high school students sign LHC experimental papers, but within a couple of months, I think this is going to happen. And she's now expanding this activity, as you say, to a big network of other schools in the UK. Okay, I'm conscious of the fact that it's coffee break time. and I'm sure that Robert would like a cup of coffee. So I think I'll, on your behalf, thank the panelists for their presentations.